Hi everyone, thanks for joining. Today is day number 9 for our SDWAN session, and today we are going to discuss about OMP. Today's session I am going to cover only one slide, single slide for entire 1 hour session. Today we are going to discuss about OMP. OMP full form is Overlay Management Protocol. So let me go and write here that today is day number 9, OMP introduction, and I'm going to present only one slide today. That's it. So before I start, do you know what is OMP and what's the use of OMP, Overlay Management Protocol? Do anyone know about OMP? Yeah, Jesus, you know, Temi, you know about OMP?
Is the protocol to exchange routes between the VSMAR and the VH?
Okay, you're right.
Maybe.
That's correct. So this is the protocol in between the edge and the control plane. Control plane, generally control plane means VSMart in our Cisco SD-WAN. Any other thoughts that what OMP can do and what's the capability of OMP? I need to draw a new diagram. Seems to be messed up. I need only this VH. Rest I will draw a new diagram only. So let me go and draw a VSmart and S-Device. VSmart, if someone has new to this batch and SD-WAN, so VSmart is nothing but the controller. So suppose this yellow circle is VSmart. I'll go and draw two VSmart, and these devices in blue, the routers that you are seeing, that is branches. These are the SD-WAN edge devices. So suppose I have 1, 2, 3, 4. So in my diagram, suppose I have 2 routers in one location, other router in one other location, other in other. So I'll go and draw some boxes here. Suppose empty boxes. Oops. This is different branch, this is different branch, and this is different branch. And these VSmart, for sake of simplicity, they are in one location. Now, because we have some SD-WAN classes earlier, so what I will do to identify these sites, you can go and assign some site ID to these branches. So suppose this is site ID 100. This is site ID 200. And this is site ID 300. This is suppose site ID 400. Okay. Okay, and connection like this. These are different ISP, green and blue. And suppose like this. One of the branch having two ISP connectivity like this. This branch assume one ISP connection. Suppose this is ISP1 and suppose this is ISP2. Okay, so now you can see this diagram. This is V Smart 1 and this is VS Smart 2. Okay, I'll come to OMP and their use. You will understand each and everything about that. Configuring this OMP and creating template for OMP is actually very easy. The important thing, we have to understand the concept of OMP, Overlay Management Protocol. Now, this VSmart that you are seeing here, this is the control plane. We know that in SD-WAN, what is happening, that we have decoupled the data plane and the control plane. That means the brain, all these devices at different location, their brain, they are located at same location, at some centralized location. That is with the VSmart, and that brain or that routing intelligence is with VSmart. That means VSmart has to take the routing decision on behalf of all the edge devices. Okay. Now, how this VSmart will take the routing decision, how the VSmart will go and create some routing policy and push to these devices, how these devices in the branch level, they can exchange their own subnets. Obviously, below these devices, below these, maybe they are connected with some other router or maybe some LAN network or maybe some own network. So below these devices, below these routers, they have their own prefixes. Suppose this is just for sake of simplicity, suppose this is 1.1.1.0/24. Suppose this is 2.2.2.0/ maybe 8, anything, or mix of so many prefixes. Suppose this is 5.5.5.0/13 or etc. So how 1.0 will come to know about 2.0 or 2.2.2? How 5.5.5 will come to know about 1 and 2? Okay, because you are connected with ISP. ISP will not go and exchange the route in between them, right? So that means that somehow these prefixes from here, it will go and reach to the control plane, and these control plane, they are working as a route reflector. They will not only tell their peer about those routing information, so they will go and tell this VSmart, and other VSmart will tell this VSmart about those routing information. You can think this as IBGP peer, and then they are working as a route reflector. Then this VSmart responsibility is this, that they will go and tell the prefixes that whatever they have learned, just as a route reflector, that they will go and tell about the information about the routes that they learn from their edge devices. So what is happening behind the scene, that this VSmart, I'm going to use the red color. So this VSmart having OMP peer with VEdge, and among the VSmart also they have the OMP peering, overlay management protocol peering among themselves, and with OMP updates they are learning the routes. So that means that the edge devices, they will send OMP update to VSmart, and obviously VSmart will send OMP update to the uh, devices so they can understand their prefixes. Okay. So at this point of time, if you have any question, please ask. And just allow me 1 minute. I'll drink a glass of water. Meanwhile, you can think if you have any question. Yeah, I'm back. You have any question? Because I'm going to make this very complicated, this particular diagram. And I want that you should understand, you must understand this, because this is the SD-WAN. If you understand this concept, 80% of SD-WAN you will understand. This is 80% of the SD-WAN concepts. The rest what is their configuration, and that's it. So this is the heart of SD-WAN. Everything is glued here in this OMP. If you remove OMP from SD-WAN, then SD-WAN is nothing. Then it's like normal router. All right. So when I'm telling you that, okay, that you have OMP peers in between VSmart and edge devices, VSmart and VS devices, or VSmart CS devices, right? So is it like OMP, overlay management protocol? Because name is quite big. OMP is overlay management protocol. It's a big name, right? So is this that OMP will send only routing update? The answer is no. Is OMP is there, that protocol is built there not only for routing exchange, it has some other uses as well. Ray, you have any question? So it has other use as well. We know that in SD-WAN, what is happening? That these devices, these branch edge devices, they are forming IPsec tunnel in between them. So at the moment you'll go and bring up the tunnel, these devices will go and form the IPsec tunnel, right? You know that in between them. So suppose this red arrow, this is nothing but IPsec tunnel in between them. So do we are doing any configuration to form the IPsec tunnel? The answer is no. Then we know that while the data plane devices, they are forming IPsec tunnel, they should exchange their IPsec key. So there are phase 1 and phase 2 ISACM policy and IPsec policy in between them. There are some public key, private key, they should get exchanged, and then they will form the IPsec tunnel. And suppose if you have 200 branches, then are you sending or receiving 200 keys from different locations to form the IPsec tunnel? Answer is no, right? Then who is managing these keys? How I am sending keys to other devices? The answer is OMP. So OMP, not only they are doing the key management. So OMP, they are not only sending the OMP updates or routing updates, but they are managing the, or they are sending the key exchange as well. They are doing the key exchange within the OMP. They are, so all these devices, they are sending their key to VSmart, and VSmart again working as a router reflector to send the key to all the other rest of the branch devices, right? Apart from that, VSmart can push the policy to VEdge or CEdge devices. Oops, I missed that. To VEdge devices. Come on. VEdge devices via OMP session, or in between them they have the OMP. So they are using the OMP session to send the routing policy. Later on, we'll learn that how we can go and create the routing policy. So VS Smart will go and push that routing policy, that centralized policy, with help of OMP to all the devices in their control plane, in their memory, or in their processing cycle, etc. Any word you can say that. Okay. So this is like, a rough overview of the OMP. I'm going to show you only one slide today. In that slide, you will understand more detail and depth about how OMP is working behind the scene. And in that diagram, in that slide, everything will be glued together. Okay. Now, if I just go back in this and mark one arrow here, you know that the OMP policy, the centralized policy, from where you will create, you have only one option. From vManage, you have to go and create the policy, right? And that policy from vManage, so the order is like this: from vManage, you will push to VSmart, and from VSmart, it will get pushed to VH or CH, right? So let me show you that slide. Okay, that slide is this. Before this slide, some definition is there that OMP. BGP is also TCP based protocol. It is working on application layer, and BGP is using port number 179. OMP is which port it is using, I need to check. But BGP is using port number 17 like that. Like that. In other words, in SD-WAN terms, sometimes we are telling OMP as a lightweight BGP. Working as a lightweight BGP, it is very much customized protocol for Cisco SD-WAN, Cisco Viptela SD-WAN. Okay. So what are the things it can do? It is TCP based protocol, runs between vEdge and vSmart, and among the vSmart. This is inside the control plane, that DTLS or TLS connection. Leverages address families to advertise reachability for TLOCs. Unicast means in between them you have TLOCs, BFD, and other address families that we can advertise. And it is distributing the IPsec keys. This is working as a key exchange transport as well. So IPsec keys, data policy, centralized policy, app aware policy, and all those policies. Right? Now, how it is working, let's see this diagram. This is actually very interesting diagram. And because I'm recording this session, you can always go back on this particular section when we have started this diagram, and you will understand this. If you understand this diagram, again, you will understand actually everything in SD-WAN. Rest part is that the what you can see, that accounting type of thing, like you are creating something and pushing to that. It's like that. This is the key feature of SD-WAN, this OMP portion. Now you have full-fledged SD-WAN diagram here. Full-fledged means that suppose if you have two branch one and branch two, Let me use my, so you can see this is branch 1 and this is branch 2, right? So you have branch 1 and branch 2. In between that, you can see that branch 1 and branch 2, in between that we have the ISP connectivity. So internet, MPLS, 4G, whatever transport we have. You know that SD-WAN is independent of transport. So transport is not that much relevant because we are sending the encapsulated packet over one transport to other transport, over one branch to other branch, irrespective of transport, either it's say internet or MPLS. Since we are doing the encapsulation of packets, so that is not that much relevant. Okay, now you can see in this portion you have two diagram. So if you are here, you can see this is a small green box. You have underlay network and you have overlay network. Underlay network in some gray color and the overlay in some blue color. So irrespective of what I have in underlay, OMP will go and do the encapsulation and it will work on top of that. So irrespective of the physical connectivity, we have this OMP that will work, and we are going to discuss about that, how it will work. Okay, now what is our goal? Our goal here is this, that site 1 prefix, suppose A is one of the prefix, that is site 1 prefix, wants to reach to other site. Suppose this is site ID 1 and this is site ID 10. You can see in the bottom, site ID 1 and this is site ID 10. So two different sites having two different prefixes, two different branches, they want to exchange their prefixes, right? So how this prefix exchange will come into the picture? Now you know that if we have VS device, you have at least two VPN. You should have at least three. One is VPN 0 for connecting over the ISP. Then you have VPN 512 for management, and then you have service side VPN. In this example, you can see VPN 1 is service side VPN. That means that the prefix that is associated with the VPN. So if I'm talking about this part, this red link going down, this is part of VPN. Let me go and highlight here. Let me clear the drawing first. Okay, so suppose this is part of VPN 1, and obviously the transport that you have, that is those interfaces, they are part of VPN 0, right? So VPN 0 connecting to the ISP, and VPN 1 is my service side VPN where I have my prefixes, right? So same thing you can see in the diagram, that okay, I have VPN 1. This is like logical representation of this router. So within this VH router, you have VPN 1, you have VPN 0. This VPN 0 is connected with the transport in this diagram. So you can see here that the device, the transport that is connected with VPN 0 with different ISP. Now different ISP, internet, MPLS and 4G having different color. We have color marking. So blue one is for 4G, this orange one is for internet, and this green one is for MPLS, like that you can see. And now you can see T-lock. We haven't discussed about T-lock so far, that we have to discuss. T-lock is nothing but transport locators. T-lock having three main attribute. So this T-lock that you are seeing here having three main attribute. They have color, encapsulation and encapsulation and system ID. Now what's the significance of system ID? If you have done class 1, I told you system ID is nothing but loop back address of that particular system. Why we are using loop back address in BGP or in other normal routing world? Because loop back address is the address to that particular device. So irrespective of how many physical interfaces you have, loop back address is something that will never go down because this is the logical IP to the system. So suppose if you have 4 physical interfaces, if any of the physical interface will go down, that interface address will go down, it will become unreachable. But if you have system IP or loopback address to that particular device, any of the physical interfaces will go. Still you have one address which is up and running. That is nothing but the system IP, system ID or system IP. ID or IP, same thing. So three main attributes you have for TLOC: color, encapsulation, and system IP. I should write IP here, system IP. System IP is nothing. You can see here the system IP highlighted 10.0.0.0.1, the system IP. Then you can see the color green, orange, blue. Okay, and then encapsulation. In this case, mostly you will see encapsulation will be IPsec because we are forming IPsec tunnel in between the branches. So encapsulation part will be same in most of the cases. Sometimes when you are using GRE tunnel or other things, then encapsulation will get changed. But most of the time encapsulation is same, system IP will be the same. Then how TLOC will be different? So TLOC will be different with respect to color. And that's why the significance of color is there. But again, these things are not part of your actual attribute, means these are something that you are putting custom made, like that you can think. These are custom made thing. Why I'm telling custom made thing is that your service provider, suppose your MPLS provider, will not tell you that you use color yellow or color blue or color red. That is that in your configuration you are putting red color for MPLS 1, blue color for MPLS 2. You know, for your ISP you are choosing your marking. They don't know about this coloring and all those things. Okay. So TLOC is nothing but the transport locator. Again, you are thinking of what is this TLOC and all. So I'll tell you in single word, TLOC is nothing. This TLOC is nothing but next hop. So TLOC is equal to BGP next hop attribute. That's the significance of TLOC, transport locator. Because in Cisco SD-WAN, you may have some fancy words, TLOC, OMP, service VPN, VPNs. Service VPN and VPN, they are actually not VPN. They are actually VRF, virtual routing forwarding. So when I'm telling you VPN 0, this is nothing but global. Actually, this is nothing but front door VRF. If you know DMVPN and all, this is nothing but one type of VRF, VRF. VPN1 is nothing but one type of VRF. This is not something that is actually very new. This is something that the Cisco engineers, they form their own company called Cisco. Their company name was Viptela. So these engineers, they are working in Cisco for 10, 15, 20 years. Then they have started their own company called Viptela, and they use the same Cisco terms there in some other name, like OMP. Again, OMP is very much BGP. TLOC is nothing but BGP next hop attribute. This VPN is nothing but VRF. So they rebranded the name for sake of simplicity or maybe some other reason, I don't know. But Again, when Cisco when acquired this company Viptela, then again they are using the term called VRF and all those things. Okay, so it's like same thing in some other word. Okay, so here we are. You can see that T-lock. All the time I'm telling you T-lock. But T-lock is nothing but next hop attribute. Next hop associated with any prefix is nothing but the T-lock. Now coming back to this point, now you will understand the things how they are glued together. So VPN0, which is your front door VRF, and VPN1, where VPN1 should go and tell VPN0. So one instance of VRF will tell the global routing table or global VRF that you have to learn my prefixes internally. Okay, and then you have to go and use any of the color, any of the T-lock to send that prefix to VSmart with help of what? OMP. And that's the thing is happening behind the scene in SD-WAN. Maybe you understood this thing now, that how they are connected, right? So what I'm telling here is this, that internally one VRF will give their prefixes to VPN0, and VPN0 will use this T-lock is nothing but next hop attribute. So suppose if you are connected with 3 ISP, so obviously all these 3 ISPs, they know that this particular prefix is A. So prefix A, right? Prefix A, when it comes to VPN0, right? So it may reach to other location with 3 path: internet, MPLS, and 4G. But prefix A, when it will go and leave my router, and where it will reach? It will go and reach to the VSmart with OMP update. When VSmart will receive this update, how it will receive? So you can see here that it will receive that prefix with 3 type of next hop. Next hop associated with internet, MPLS, and 4G. Okay, and when the VSmart will receive this prefix with 3 different color, or in other words 3 different T-locks, so he will understand that this particular T-lock is associated with this particular edge device. Why? Because they are coming with a unique system IP. System IP will be unique throughout the fabric, right? So VSmart will understand with the system IP that it is coming from this branch, and VSmart will understand with the next hop that it is coming receiving to me via these ISP or these service provider or these transport. Okay, so VSmart has to identify with the OMP update that what is the prefix and what is the T-lock. What is the prefix and what is the next hop? Both are same thing. This is the 50% of the uh, explanation. If you have any difficulty in this, you please feel free to ask. You have any question here? Please ask. You are able to understand, right? It's simple thing only. but I need to tell you that how it is happening. So that's why I'm trying.
That's good. Prakash, we clearly
Okay.
get it out.
All right.
Can you do like just an overview again, like a summary?
Yes, yes, why not? I'll summarize this. So because there are so many small pieces, we have to glue them together, right? So you know that you have service VPN where you have the actual prefix, where you have either source or destination, right? Now that particular service VPN needs to reach to VPN 0 because that is your actual transport VPN. So service VPN has to reach to transport VPN that is internal within the system it is happening. Now that particular prefix from transport VPN or VPN 0, how it will go and reach to other side, in that part OMP will come into the picture. So OMP will take help of the next hop attribute that is nothing but TLOC, transport locator. And we know that within the vEdge and vSmart, we have OMP peering. They are OMP peer. So that means any information that we have with the vEdge, if we advertise to OMP, it will reach to vSmart. Now, if vSmart will go and receive that information, obviously he will open that information and he will see, oh, prefix is A. That means that, okay, 1110, but from where it is coming? How vSmart will come to know that it is coming from branch 1 or branch 2 or branch 3? So then it will analyze the TLOC. In TLOC, you have three information. What information you have in TLOC? In TLOC, you have something called system IP that is unique to the box. With help of system IP, VSmart will understand that it is coming from branch 1, VH1. And then with help of color, VSmart will understand it is coming via MPLS or internet or 4G. And IPsec is like common. So these two are deciding factor for TLOC, actually for OMP, to understand that which particular device, which particular transport. Now, system IP will tell, sys IP will tell which device because system IP is unique to the devices, and color will tell which transport I am receiving this. Now, why these things are important? Because again, VSmart is working just as a reflector. VSmart is working as a route reflector. The route reflector, and VSmart has to reflect that route to other branch with OMP update. So the next portion you can see that VSmart is sending the route advertisement to other side. Now other side, when they receive the route, then how the other side will come to know that it is coming from internet or MPLS or 4G? Again, they have to go and read the TLOC information. So TLOC information become very important to understand that which particular system it is coming and what is the transport. Right. So you can see that OMP and TLOC, they are working parallelly, and then they are helping the different branches to understand the routes with help of VS Smart. Okay. Again, if you
Just a
have
quick
any,
one. Do
yeah,
do you have a like a example of the composition of the T-lock?
we have full-fledged slides on TLOC. You can say TLOC, 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 significance of TLOC, TLOC example, TLOC. Don't worry. At the moment, and I will explain you and I'll show you in the device as well. So what is T-lock? What is the attributes of T-lock? How it is and everything. And I have full-fledged slides for OMP as well. This is not that OMP I have ended here. We have full-fledged slides OMP. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25 slides we have for OMP and T-log. So don't worry. At the moment, I just wanted you to understand the concept. Behind the scene, this is happening. And then we will check the attributes of OMP, attributes of T-log. Like BGP, in BGP you have 13 attributes, different attributes are there in BGP to give you best path selection. Likewise in OMP also we have 7 to 8 attributes to provide you best path. Okay, and T-lock also, T-lock is helping that OMP to select that best path. Okay, I'll come to that. Apart from this question, you have any other question? Okay, so roughly you understood that you have VRF, you have global VRF, you have site-specific VRF or service VRF. The service VRF will send that route to the global VRF. Global VRF will use T-locks and OMP to send that update to VSmart. VSmart is working as the route reflector. It will reflect the route to the other side. So B will get to know about A and prefix A will get to know about B. So that means they will get the updates, right? Simple, straightforward. What are the new things we have to learn? We have to go and learn the different attributes of OMP, and then we have to go and learn the different attributes of T-lock, right? So let's go and learn. I'll come back to T-lock. Different attributes of OMP and what is OMP first of all. So let's understand. The Viptela Overlay Management Protocol is a protocol responsible to maintain the control plane. We know that. To maintain the control plane. Why? Because OMP is working in between VSmart and VEdge. It is not running in between two different VEdge. Okay? Then OMP will do these four things. Orchestration of overlay network, distribution of service level routing, distribution of data plane security parameters, central control and distribution of routing policy. This is the use of OMP. Now we have one diagram, this diagram, our lab diagram. In our lab diagram, if I go back to our lab diagram, we have our lab diagram. I'll explain you this in our lab diagram. This is our lab diagram. Okay, I'll copy this. Okay, and this is our lab diagram, right? Now in this lab diagram, you can see this lab diagram. If I ask you that means what type of routes the OMP will exchange? Okay. Now in this lab diagram, if you see, do I have firewall here? I haven't put any firewall here. So for example, this is, assume that this is firewall here, right here, firewall. Okay. Now you will see that what are different parts of OMP. So whatever routes you have within your fabric, either it's generated for firewall, means location of firewall, routes that is below that edge devices. You can see edge device, below that I have prefixes 10.4, 10.3, 10.3, 10, etc. Or in the data center 10.100. These routes, firewall location route and the T-lock route. T-lock is nothing but your next hop. So these locations, this is the location. This is my next hop, these next hop. So where whatever location I am putting this red arrow, whatever places I am putting the red arrows, those are nothing but your fabric route or your OMP route. Actually, OMP route having three different part. OMP route is your this red one. Red one is nothing but the Viptela routes or OMP routes. The green one is the location of your security device. That is also one part of OMP route. And then you can see this T-lock. Suppose this is blue color. I'll make this blue. So this next hop route that you are seeing, that is also your OMP route. So this these red arrows, this blue arrow and this green arrow, these are three different parts of your OMP routes that I will explain you. I'm going to explain you. These are nothing but the OMP. And if I minimize the diagram, you can see here in the same diagram, the red arrows, the blue arrows, and the green arrow. So in your fabric, the location of your security devices like firewall, IPS, IDS, any security devices, that is part of OMP, that is part of fabric. In your SD-WAN fabric, the service level routes, means the VPN 1, 2, 3, 4, non-VPN 0 or non-VPN 512, they are part of your OMP routes. In your fabric, your T-lock, your next hop, system IP, color, encapsulation, those are the next hop attributes. They are also part of OMP routes. Three different routes are there, part of OMP routes. That is also explained here. In this diagram also you can see that T-lock, 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 V-route, 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 V-route. I need to highlight, otherwise I'll miss. One second, let me use the marker. So in this diagram also you can see this V-route, V-route, V-route. This is nothing but the service route. Then you can see this firewall, location of this firewall in the diagram, location of, this is other type of Viptela. This is V-route, V-route, V-route. This is your V-route, V-route, V-route. And then you can see T-lock, 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 T-lock. All these portions, they are part of OMP. Three different type of OMP routes are available. T-lock OMP, Viptela OMP routes, and firewall location or service side OMP routes, like that. Okay. And again, these things you will understand slowly. Slowly you will understand. It will not come within one day, one session. You will configure it, you will work on that, and you will understand that. So you can see OMP routes. You can see service routes. There's nothing but the location of firewall. You can see these transport routes. They are three different part of OMP routes. Okay. So as I told you earlier that today I will explain you just one slide. My main focus was just this particular slide. I don't want to go beyond this just for today's session. Let's stick with this. please go and watch the recording at least one time, minimum 1 or 2 times. And then in next session, we will work on OMP only, and we have one small lab. I will create one route here in one of the device, and I will show you that how it will go and reflect to VSmart, and then how it will go and reflect to the other side. That is the lab I will show you in the next class with some theory. Okay. If you have any doubt, you please ask. Let me pause the recording. Hi everyone, thanks for joining. We are in day number 10 today, and today our topic is OMP part 2. What we will do today is that I'll go through the theory of OMP, and then we will perform one lab task. So let's start. We know that OMP is Overlay Management Protocol, and OMP is in between VSmart and VSmart to VEdge. OMP is responsible to manage the overall overlay. Overlay means that it will go and manage the routing update from VSmart to VEdges. It will go and work as a key server, means with key exchange. It will help in the key exchange. Key server is actually your VSmart. And then finally, whatever policy that we are creating, routing policy that we are creating within the VSmart, that will get pushed down to the edge devices with help of OMP updates. Okay, now OMP having three different type of routes: OMP routes or Viptela routes, service routes. Service routes means that the location of that particular security appliance within the fabric. And then finally, the TLOC routes. TLOC routes is nothing but your next hop addresses associated with any of the service side prefix. So when we are talking about service side prefix, that is nothing but your Viptela routes or OMP routes. Those OMP routes, when you are attaching that with the next hop, that will become your TLOC. So that's the logic we have here. That's why all the definitions are here. What is OMP route, what is service route, what is the TLOC route. In this diagram, you can clearly see that where exactly what are the portions available, what are the things available. So when we are talking about the OMP routes or Viptela routes, so here you can see in the red, all these are Viptela routes. Service side routes are, all service side routes are actually your Viptela routes. Then if I go and select the color, let me go and highlight with some other color. So the blue color, I am going to highlight the location of the firewall. Oops, not this color. Location of the firewall, let me go and use this, the star. This star is nothing but your security appliances identification or location of your services. Services means security services here. So that is nothing but your identification of services, that is type 2 of OMP routes. And then finally, the third one is nothing but your TLOC. So let me go and use this arrow for TLOC. TLOC is nothing but your next hop routes associated with the next hop here. So these are your TLOCs. These are your TLOC connecting with the ISP. These are your TLOC. So these three routes you have in the fabric. Now, apart from this, do you have any other route that VSmart should go and know? The answer is no. This is exactly the part of routes you have. What is the significance of this OMP service or OMP security identification routes? Because later on, if you have any prefix later on that you have, you can go and redirect that prefix towards the firewall, and from that firewall, it can go anywhere. So that's why we have this location of the security devices. That is important. We have such type of lab later on in this in our lab section. We will check that. So OMP route, what is happening that within the service side, within the V route, you can run anything. You can run BGP, OSPF, EIGRP static. You have to redistribute that to the OMP, because within VEdge and VSmart, what is the protocol? OMP. So that means your local routes should be redistributed within the OMP. So your OMP will come to know. At the moment your OMP will come to know, it will be advertised to other side devices, because your VSmart is working as a route reflector. So anything you can run in your edge device, any type of routing protocol, but it should get redistributed to the OMP. And likewise, OMP should be injected towards the local route. Now there is one interesting question here. That question is this, that are you redistributing the BGP to the local route? Answer is no, right? We are not redistributing the BGP table to OSPF. Why? Because BGP tables are big. And if you redistribute that big routing table to your local routing table like OSPF or EIGRP, it is not wise to do that. So if we have to go and redistribute BGP or OMP, OMP is also a big routing table, right? So while doing the redistribution, you should go and use some sort of route filter. Later on, we will see that yes, we'll go and use some sort of route map or route filters while we are doing the redistribution from OMP to local routes. Okay, so that part will come later on into the picture. Let's move on and let's understand that what attributes we have for the OMP. Remember that OMP is very much like a customized BGP, and BGP you have so many different type of attributes. I think there are 13 attributes, right? Likewise in OMP also you have so many attributes. Some of the attributes are new because protocol itself is new to us. So you will see that you have T-lock, origin, originator. I'll come to all these things. Preference, service, site ID, tag, VPN. So 1, 2, 3, 4, 5 here, 6, 7, 8. 8 attributes at least you can see here related to OMP. So OMP having one attribute called T-lock, it is nothing but next hop type of attribute. Origin means who is the originator of the prefix, from where it is coming. So origin and originator, you can see that origin, that source of the route, such as is OSPF BGP or connected static, that is the origin. Originator means who is originating that route, from which particular edge it is getting originated. Then preference. Preference is something that is taken from BGP. There are some attributes you can see here. Actually, at least this preference one is there in BGP as well. So if higher preference, if higher OMP route preference, in this case in OMP higher is better. So if two different routes are coming, if OMP route preference is higher, that will be preferred. How this path selection is happening, we have slide for that. I will show you after 5 minutes. Then service. Service means your firewall location that is associated with OMP. Site ID, we know that what is the significance of site ID. Tag value is there in Cisco as well, that you can go and associate the OMP tag as well. And tag is optional. This is transitive. That means it is going via the flow. Means when OMP is sending update, with that update it is sending the tag value as well. VPN, we know VPN is again the tag, or the VRF is again the tag for network segmentation. So these are the part of OMP attributes. How it is useful, we will see in 5 minutes. These attributes are useful to do the best path selection. Likewise, you will see that for TLOC also we have certain attributes like TLOC, private, public address, carrier, color, encapsulation. In TLOC also you have preference. So in the best path selection, this preference will also come into the picture. So far we know that TLOC having three main attributes. What are these three main attributes? System IP, color and encapsulation. So here you can see the color, the bottom. This is the color one. And you can see the system IP in the next slide. System IP is not listed here, but system IP will be there, and color and encapsulation. Apart from that, you can see here the encapsulation. Apart from that, you can see two more attributes which is very much there in Cisco as well, preference and weight. And we know from our BGP knowledge that weight is something called local attribute. Weight and preference, they are interesting attributes. Generally, we will go and use the preference value, and that preference value will go and use with the OMP preference, not with the TLOC. But yeah, to take some local decision, you can go and tune the TLOC as well. Again, in upcoming lab section, we have to go and utilize this TLOC options related to TLOC routes. We'll see that how it will be useful in the lab section. Okay, so I will then you will understand more about TLOC. But at this point of time, you please understand this, that you have VIPTOLA routes, and the significance of TLOC is this, that TLOC is working as a next hop attribute. So this particular section point is very, very important. This section is very important, that TLOC is same as BGP next hop, TLOC having system IP, color and encapsulation. And it is very, very significant, because how VSmart will come to know that which particular system IP and which particular ISP I am receiving this prefix. Okay, great. One of the example for TLOC, again you can see that suppose if you have system IP, so if you see, okay, if you focus on this part, that is branch number 2. Branch number 2, there is one branch 2VH1 whose system IP, assume his system IP is 10401. And suppose if this particular branch having two link, one link is going in this direction, one link is going in this direction, that means this TLOC is different, this TLOC is different. So what is the TLOC in this location? If this is the MPLS link, how we can identify that? So you can identify this link with system IP, color and encapsulation. So system IP, color and encapsulation, system IP, color and encapsulation. So obviously the system IP will be same. Encapsulation is IPsec, that is same. With color only, one is blue and one is green. You can identify that the VSmart will identify that this is coming via MPLS or this is coming via internet. So that is one of the significance of TLOC. That's why we have this particular slide here. Now the very important topic we have, that how OMP will go and choose the best path. Now before coming to this particular slides, we have 3-4 slides related to that. I will go and show you one lab related to OMP. So let's do the lab task, and then I will come back to this particular slide and explain you that how it is working behind the scene. So what we are going to do in this lab today, we have the lab diagram here. In our lab, we have data center and these two branches in below. What we will do in this lab, suppose we have DC data center. I will go log into the device. For example, I'll go and log into this particular device. I'll go and create one loop back. For example, 9.9.9.9. I'll go and create one loop back. 9.9.9.9. Okay. And suppose this is loopback 100. I'll create one loopback called 100. I'll fix the IP 99999. At the moment I'll go and fix that IP, the loopback will be connected interface, right? So that means that within OMP, if there is one command, OMP advertise connected, that means that this 9999 prefix will go and reach to VSmart. So somehow this will go and reach to VSmart via two TLOC, TLOC MPLS and TLOC Internet, right? So we'll go and then log into VSmart and we'll see that over VSmart will have two TLOC, TLOC 1 and TLOC 2. TLOC 1 will be via, for example, MPLS, and TLOC 2 via internet. We'll see that. Then what VSmart will do, since VSmart is working as a route reflector, right? So that means that VSmart will take that route and then it will go and reflect that route to the devices. So again, I will go and log into these devices and we will try to see that this particular loopback that we have created is reaching to these devices or not. Now, the interesting thing here is this, that the loopback that you create, it should be part of some VPN or VRF, right? So what I will do that just to make this little bit interesting, this section, I'll go and place this over VPN 10, this loopback. And again, I will go and create one more.
Sir,
Mhm.
sorry to interrupt you. Someone is waiting on the lobby to enter to the meeting, to the training.
Okay, sorry for that. I haven't seen
Yeah,
that.
please. I think it's Terry or I don't know the name.
Temi.
Temi.
Okay.
Yeah,
Yeah.
Temi. Send a WhatsApp message. Sorry.
Okay.
Go ahead.
No problem. I allowed him. I will try. And then what I'll do that I'll create uh, one more loop back within other VPN, and same process, it should come and reach to these devices. Okay, so let's perform this particular task. And because we have to go and create template and all those things, I will not do this. I will go and detach the device from the template, and then I'll create these loopbacks from CLI. Later on in the future sessions, we'll do these things via the template. So we have this vmanage. Let's go here. Configuration and template and device template. One of the device I will detach. For example, DC, because if you detach, then you can do some local changes. Otherwise, you can't do any local changes. And let's log into the DC1 VH1 here. Let's go and check show interface description. You can see that we have VPN 10, VPN 20. So I'll go to VPN 10, interface loop back 100, IP address 99999 255.255.255.255. Okay, why it is not taking 9999? Okay, so you have to give like this here, the IP addresses with cider. It will not take subnet mask in this device. 32, no shut. Will you commit and quit and show interface description? So now you will see that we have one loopback 100 part of VPN 10 which is up and running. So now let me go and log into the VSmart. How VSmart is getting this? Show OMP routes. So many routes it is getting, and we need to go and filter that. So you can use this tabular format. And 999, you can see here, part of VPN 10 999. It is belonging to this system IP, and this VSmart 1 is getting this from this vEdge and from this VSmart. So what I'm telling here, if you go and check show OMP peers, you will see that the VSmart, who are their OMP peer? So their OMP peers are all the vEdge devices and the other VSmart, right? Now, if you see this last column, you will see that from 10101, that is DC1 vEdge1, it is receiving 22 routes and sending 44 routes. It is not installing any routes. If I go here and type show OMP peers, now you will see that it is receiving 44 routes from where VSmart is sending 44, vEdge is receiving 44, right? Then it is installing how many routes in their routing table? 24, and it is sending 22 routes. It is sending 22 routes. How many VSmart is receiving? 22 routes. VSmart is not installing, because why it will install? It is not working as a forwarder. So it is receiving and sending, right? Now here you can see that below one is also. So in our lab, if you see our lab, just to make this clear. So in our case, we have two VSmart 1 and 2. We haven't set any priority to VSmart, but these devices are intelligent enough. So one is working actually as a primary and other one is working as a standby. So that's why if you see here in the below, suppose we are in DC1, vEdge1, you will see that from this VSmart, it is installing 24 routes. But from this VSmart, it is installing 0 route. If anything will happen with this VSmart, you will see that the counter from 0 will become 24, because then this will become the primary for this vEdge. Okay, so at the moment this is the arrangement. Now let's go back to the VSmart. So we are here in the VSmart. Now you can see that this particular route. So can I go and check only this route? So let's see. So OMP routes and then 9.9.9.9/32. So this is detail about this route. Received from this is the path ID, this is the label. Internally they are putting these fields. CR. If you go and check the, there are some flags. One second, I'll show the. One second, let me see. Yeah, I can see the code. C for chosen, I for installed, red for redistribution, rejection, looped, resolve. In our case, this is C and R. Okay, one sec. That particular prefix. Okay, so C and R. C, capital C, chosen, and capital R resolved, right? I will show you other flag as well, C and R. Then loss and other things, summit. Then you can see this OMP attributes: originator, type, T-lock, ultimate T-lock, overlay ID, site ID, reason ID, affinity. What is meaning by affinity? We'll see that later on. Reoriginator, preferences, etc., etc., etc. But let's see this T-lock. System IP color encapsulation. Now with this T-lock, below also you can see T-lock. So that means that VSmart, while VSmart is receiving this particular route, VSmart knows that I am receiving this route over MPLS and over internet both, right? Internet and MPLS. Now, if any protocol is there, OSPF is running in data center. So if any protocol is there, let me show you. It will show you that protocol is there in that particular route as well. I'll show you that some of the route having some protocol. This is the origin protocol connected. Let's focus on origin protocol. So few of the routes, few of these service routes or origin protocol, see OSPF. So which particular route having OSPF? 10.1.13.0. The VSmart knowing this thing, see VSmart only understand what? OMP. But when you are sending this particular route 1013 from yourself to VSmart 10113, 10113, when you are sending this particular route to VSmart, you are using some redistribution. Let's see where is that 10113. 10113 is something that is not originated by me. Even I am also learning that route from somewhere, maybe some connected device in service side VPN from where I am learning this. So show OMP route 10.1.13.0/24. Let's see. Within VPN 10, I am getting this route and it is coming via OSPF external. Via internet, via via MPLS it is showing. Okay, let's do this thing. Show OSPF routes for VPN 10. So you can see here that with OSPF is running within the VPN 10. So if you go to VPN 10, here we are running OSPF over this interface. Interface is Gigi00, and within Gigi00, you will see here that Gig00 having OSPF neighbors. So 3 routes, data center. So suppose I am VH1, I am data center. So logic like this, that this is your VH, DC VH. This is my VPN 0 and this is my VPN 10. Now my VPN 10 may be connected with any of the router. let me draw correctly. Any of the router and which router is running OSPF. So that means that this OSPF that is there, right, in this service side VPN, right, this OSPF somehow it has to go here where we have OMP. That means you are redistributing OSPF within OMP. And what are the prefixes? 10, 1, 13, 14, and 15. How I can see this redistribution? So once you are here in this section, you can see this portion below. OMP, advertise OSPF external, and a static also there. So if I go somehow, if I go here to conft OSPF, oh, I don't have that option, means from CLI to run that. If I do no advertise and commit and quit, and we'll go and see VPN 10. Actually, I'm unable to remove this command due to some reason. Let me try. No OMP, advertise OSPF. Yeah, I have to go to VPN level, commit and quit and show. So now you can see that OMP, we have removed that statement. And if you go here and check that particular route, 10.1.13.0 13.0/24, right? So now you will see that VSmart is not getting that route from 10.1.0.1. This is the other device, right? This is the other VH from where it is getting this other VH. Originator is other. Earlier, so if I go and put that command back, you will see 10.1.0.1 and 10.1.0.2 both. So if I go here and do tab, so now you will see that it is getting via 10.1.0.2, 10.1.0.2, 10.1.0.2, 10.1.0.2. Now if I go back here, VPN 10, OMP, advertise, OSPF external, commit and quit. And now if I run this command, you will see 1 and 2 both, right? So that means that your OSPF need to be advertised to OMP to reach to VSmart. Now I am not going to other devices. We know that it will reach to VSmart, and from VSmart, where it will go? It will obviously go to other VH. So from VSmart, you have connectivity to other VH, right? So suppose this is, for example, this is branch 1, CH1 that you can see here. I will log into that, and this is DC1, VH1. So point here is this, that if VSmart will come to know about the OSPF route or one loopback that we have created, it should come here to branch 1, CH1. So why not go to branch 1, CH1 and verify that how this is getting that. So if you come here and if you type so OMP route, it will not work because CS devices command is not supported. In CS devices, you have to type show SDWAN and then OMP, and then routes. Okay, and now we can see here 10, 13, 113, etc. Let me clean this screen. Mm, mm. And let's focus on first of all 9999, and then I will come to VPN 10, because VPN 10 having this 99999, and I can't see this, so it is not getting 99999. Oh, I think we have done something here. Show run VPN. That's good actually, that you are not receiving 99999 here. Any answer that why it is not coming here?
We are redistributing OMP on this edge device. I don't know.
Yeah, you're right. So see here, OMP is advertising OSPF and static. And what type of route we have? This 999. This is something called
Connected.
connected. Yeah. So
Connected.
that means that we have to go to VPN 10 OMP advertise connected. And now if you come here and search, it should come CIR. CIR means chosen, installed, and resolved. That means now you can ping to this location within this VPN. So I can ping to 9 with the VPN 10. CS things are a little bit different. Ingress, timeout, validate, data, size, repeat, source, source 10. Recognize command. Yeah, you have to give the source IP sims. VRF and some means it look like CLI, but you know that it's not there in CS and VS. The CLI commands are a little bit different. Here it will work. Ping whatever you want to ping. For example, 10, 10, 10, 10, which is not assigned to anyone, but here the VPN thing will work. But in the CS not work. So far you are able to understand, right? That how routes are reaching to the VS Smart. So you can see in this diagram that how routes are reaching to OMP, like OMP is running in between Edge and VS Smart, and from here it will go and reach to the other location. Any doubt in this part? Correct, right? And likewise, if you want to send something to the devices below your C edge or V edge, you have to redistribute those things within OMP. So then you have to go to OMP and then you have to redistribute OSPF. So it's like both way. Okay. Any doubt in this? If no doubt, then we will go and complete the theory. If you have any question, please feel free to ask. Okay, so we are moving and we are completing the theory. I think this part is clear. Oh, I told you earlier that we'll go and create one more VLAN, one more loopback within the VPN 20. So let's do this quickly. Conft and VPN 20 and interface loopback, for example, let's take 20 and IP address 20.20.20.20/32. No shut, commit and quit. And now, because we have done this OMP advertise connected, so I can go here and check show OMP route. Which VPN is that? VPN 20. So show OMP route 20.20.20.20/32. It should come here. If it will not come here, that means that within the VPN 20 also we have to do this OMP advertise connected, and then you should see this. Right? Great. So let's go back to the slide and let's see the rest of the best path selection criteria. So how OMP doing this best path selection is almost similar to BGP best path. First of all, it has only 7 checks. First of all, it will check that the route is valid or not. Now, how someone will go and check the route is valid or not? OMP route is valid or not? How you will understand? Some parameters may be there with that it has valid AD value, it has validity and all those things, right? So some parameters are there just to check, verify that this is not a forged route, this is not a spoofed route, this is something legitimate route. So MP route having valid next hop or not, it will check that. Now once it will see that, okay, this has validity, this has valid next hop, then it will go and check the next item. What is next item? If the OMP route is valid and if it has been learned from same viptela device, select the OMP route with a lower AD value. So that means if you are running EIGRP and OSPF, so OMP will check that whose AD value is lower. So EIGRP is 90, OSPF is 110. So it will prefer EIGRP over OSPF, right? Or if you have some static route, so it will prefer a static over EIGRP. Now, if AD distance are equal, means suppose both are coming from same AD, then it will go and check the OMP route preference. Now your OMP attribute will come into the picture. Route preference, which is higher is more preferred. And this is something that you can also put. So while creating centralized policy, we have option to assign the route preference. We can configure it. So we can select that if ADs are same, we can go and put some route preference value. So this will get preferred. Now suppose if item number 1, 2, 3, they are same, then OMP, then they will go and select the T-lock preference. So we know that like OMP, T-lock also having preference, and this is also something that we can go and configure within the policy segment. So it will go and prefer the T-lock. If your item number 1 to 4, they are same, then it will go and check the origin. So is origin connected, static, eBGP, OSPF, etc. So what does it mean by origin? Whenever OMP, they are receiving the route, they are checking the origin. So if origin is a static, so you can see here the order, connected static eBGP. Why? Because actually their AD values are less. So connected AD value is 0, static is 1, eBGP 20, OSPF having 110, IBGP 200, unknown 255. So likewise, they will go and select in that order. Now suppose if 1, 2, 3, 4, 5 they are same, then OMP will go and select the route with the higher router ID. That is also we can go and configure router ID. Now if 1 to 7 all those parameters are equal, then what this OMP will do? So here you can see, if the router ID are equal, a VH router select the OMP route with the higher private IP address. Private IP address is one of the attribute of TLOC. TLOC private address. I will show you that in a while. Just after 2 minutes. Private IP, and if 1 to 7, if everything is same, that means the OMP will go and install both of the routes. Both will get installed in the table, in the OMP table. Okay, now before moving any further, let me quickly go here and give you some important information. OMP. When you are talking about OMP, so OMP having 3 types of routes, right? V routes or OMP routes. B, service. Service here means some security appliance routes. C, TLOC routes. Okay, you can go and check the OMP peers with show OMP peers command to check how many routes you are receiving, how many routes you are installing, how many routes you are sending, and show OMP routes detail will give you all the attributes info. These are very important thing. Now, point number 1, if you have to go and check the OMP routes, service route and TLOC routes, how you can go and verify. So once you are here, you can go and check, show OMP question mark. You'll see that you can go and check the actually SaaS routes, Cloud Express, we'll discuss later on, multicast also, but routes, services and TLOCs. These are the 3 that you can see. So OMP routes is nothing but the output related to service side VPN routes, VPN 10, VPN 20, etc. Then you have option to check the service. If you have any firewall VPN, you can see 10, 10, 20, 10 where you have firewall and rest VPN, it is showing like this. Then if you go and check show run VPN 10, you can see this firewall is within VPN 10. So that's why it is showing the originator of this firewall and VPN. It is showing that. And then finally, you can check the show OMP TLOC. So it will tell you that the TLOC information, system IP color and encapsulation with the public IP, private IP, all those details. So all these informations, we are smart having all these information, and according to these informations, they are working, right? So apart from that, if I ask you that do you need to understand other points as well? So other point is that you should know the OMP best path selection, and then you should know the OMP redistribution. Later on, OMP will come with vSmart policy that we'll check later. Okay, but at least you know up to point number 1 to 5 how it is happening. The redistribution will also come later. We have lab related to redistribution. At the moment, I have shown you that OMP advertised the redistributed connected OSPF, but later on we'll go to OMP and redistribute some route policy. We'll check that. We have lab related to that. Okay, so now what is our task? Let's go and complete our slides. So here we are. Before moving any further, I'll pause for 1 minute. If you have question, you please ask. You have question, please ask.
Okay. You will review later how to select the best path for the route versus, for example, MPLS versus internet or internet versus MPLS.
Yeah, so that is both are best actually. Both are by default, both are best. If all the attributes are matching, so they are best. If you see our lab here, configuration here, if you go and check the OMP routes, you can see that they are learning over MPLS internet. Why? Because this particular prefix, everything is same. So if all the attributes are same, they will install both.
But they will do like a load balancing between both, or how they work?
Yeah. So they will do always, they will do load balancing. By default,
Is there any way to prefer one?
we can go and put some policy. So it will go and prefer MPLS over internet.
Okay, we'll review this later.
Yes, we'll do it
Okay,
later.
of course, okay.
Yeah. And not only that, route load balancing we have something called app aware routing as well. If certain application you want to go over only internet, it will go over internet. If you want to go over MPLS, it will go over MPLS. So we have one policy called application aware routing policy and lab related to that. In that you will see that if you want that particular application or that particular prefix go over that circuit, it will prefer that circuit only. Okay. All right. So let's go back here and check the rest of the slide. So what is graceful restart in this OMP? Actually, the theory is there related to graceful restart and some of the theory related to timers of OMP. I'll come to these slides. Let me go and finish the redistribution part first, and then I'll come back to that. We'll see that in the action as well. So now I told you that, see, redistribution, how you are doing the redistribution between normal protocol, like think like EIGRP OSPF. So how you can do redistribution between OSPF EIGRP? Same way we have redistribution between OMP and other protocol. The only thing here is this, that the keyword. Now when you can see here the keyword is little bit different. We are not using the key called redistribute. So if you are injecting something to OMP, you are going to OMP and you are using the keyword called advertise. But when you go to OSPF, you will use the keyword called OMP. That's the only change. In normal Cisco world, always we are using redistribute keyword. So go to OSPF, redistribute EIGRP. Go to EIGRP, redistribute OSPF. But here, go to OSPF, redistribute OMP. But when you're calling something to OMP, go to OMP and use the keyword called advertise. That's the only difference. Rest everything is same. So that's why you can see that we are going to OMP and advertising BGP, OSPF, etc. Either VPN level or OMP level. Both level, you have this option. Then when it's come to calling the functions to the calling the OMP to OSPF, in that case, you have to go to the that particular protocol, and then you have to use the keyword called redistribute as it is that you have here in the configuration. And not only that, you can use this redistribute. So let me show you that. Later on we have lab related to that, so don't worry about that. Not only that, you can go and do this, but while you are doing redistribution, say OMP, you can use this route policy as well. So you don't want to redistribute whatever you have in OMP to your local protocol, right? Otherwise your routing table will crash, because OMP table, BGP table, they are very, very big. So that means you will create some route policy, some access list, some prefix list, and that a small portion only you want to redistribute from OMP to your OSPF, right? So that's why we have this task. This task is referred in SD-WAN, this task is referred as a local policy. We have two policy. We have central policy and we have local policy. So in local policy section, we will do that. And this task is there even in the CCI blueprint as well, in the exam blueprint as well. So this is important, this particular command. We'll check that later. Okay, let's go back here, and that's the AD values you have for all those parameters. Now only two things left here related to OMP, that what is graceful restart in OMP and about the OMP timers. Okay, so I'll explain you this. Graceful restart and timer. Timer is like normal timer. In OSPF also you have timer, right? Hello timer, dead timer for point-to-point link, NBMN, non-broadcast network access, and the point-to-point link. Right, so like the OMP also you have timers and all. I'll explain you that. Let's understand the graceful restart first, and then I will explain you the timer. So suppose I have two VS Smart, and suppose I have three VH devices, and assume that you have only one ISP, just for sake of simplicity, one ISP. This is ISP, okay? And then you have connectivity. You have connectivity, okay? So now here you will see, you think like this. Suppose this is your control plane, right, on top, and this is your data plane. Data plane means that all these devices, they have IPsec connectivity. Your data forwarding is happening within this green line. These are IPsec tunnels, right? How they are forming the IPsec connectivity? Because OMP, VS Smart OMP, they are telling that who is your next hop. According to that, form the OMP. What is your key? What is your peer key, IPsec key? According to that, you form your IPsec tunnel and route exchange according to OMP update, right? That's the key here. Now, what will happen if this will reboot or this will become offline? Maybe some ISP failure, maybe this link failure, your VS Smart is down. What will happen? Point here is this, that whatever last known configuration these devices they have, they will work, because your control plane is fail, still your data plane is up and running. So that means data forwarding will happen. But question here is this, how long? How long this data forwarding will happen as per last known information? First thing. Second question here is this, that if my VS Smart or the control plane will come back online again, what will happen? So for these two scenarios, we have something called graceful restart. So let me explain that what is graceful restart to you. Okay. So here you can see this is a scenario. If your data plane, if your control plane will go down, your data plane will still forward the traffic, and default time is 12 hours. Till 12 hours, they will assume that I have all the known information and it will work. That timer, I think that is from 1 second. Yeah, that timer range is from 1 second to 7 days. By default, it is fixed to 12 hours, that timer. If your control plane will go down, that there is one command, timers graceful restart. You can go and change that. So if I am here, graceful restart timer, you can see that is from 1 second to 7 days. Default is 43200 seconds, that is 12 hours. That you can change. You can make this to 5 seconds, suppose 600 seconds, 5 minutes, etc., etc. So point here is this, that if your VS Smart will come back online, then what will happen? So for that, I have one other slide, unfortunately not there. Yeah, so here you can see. So what is happening, that once your VS Smart will come back online, then VS Smart, they are sending EOR packet, that is end of rib. End of rib means that now I am back online. So whatever entries you have in your edge devices, flush that entry and get my new update and work according to new update. That's the logic behind the graceful restart. If you have any difficulty understanding this, you can ask. Say OMP timers. OMP, we are already in OMP timers, question mark. You can see graceful restart timer and EOR timer. This is something end of rib. By default, this is 5 minutes. By default, it will go and send the end of rib updates after 5 minutes once VS Smart is up and running. Otherwise, if you want to change this timer, you can go and change this. You can see 1 second to 36 a second, 3600 seconds. That's the timer. By default, this is 300 seconds. That means 5 minutes. Right? I think 3600 maybe 1 hour. Okay, so this is these two very important timers within OMP. One is end of rib timer, one is graceful restart. Apart from that, you know that what is hold down timer and what is advertised interval. This is nothing but the hello timer and dead timer. All the protocols, they have the hello and dead timers. Like that OMP also have. If I do show OMP, what is that command to see the timer? Let me show you that. Show OMP PS, yeah, detail. Yeah, if you do show OMP PS in detail, then it will tell you all those important information related to timers and all. So here you can see that, let me show you that. Hold down timer, 60 seconds. This is the uptime. Graceful restart supported, set to 12 hour. These many hello sends, these many hello. Handshake send after every 1 second is sending the hello. Routes install, route sends, IPv4, IPv6, tlog send, tlog install, services routes information, multicast route information, right? Policy sent, policy received, we haven't configured it. So all the information related to peers, it is sending the updates. Okay, so this is the full information related to OMP, and you can go through these slides and everything. Now you should understand most of the things here that is there in the OMP. Hey guys, over to you. If you have any question, please ask. This is actually very important video, not only for your SD-WAN knowledge, but for your CCI training as well. This video is something like very fundamental, that behind the scene how things are connected together. If you have any issue, which location you can go and verify, which particular route or origin or attribute you can go and verify, and according to that you can fix it, right? So this is very important video. You can watch this 2 times and try to do the lab from your side at least 1 time. Create one loop back like I have created. If you want to test yourself, you can create the loop back from GUI as well. Try to create the loop back from the GUI and then do whatever operations I have done today to verify that. We are very much done for today's session. I will not start new topic today because new topic means at least 30 to 35 minutes. The new topic, what will be the new topic for next session? That simply we'll go and start the policy. One of the toughest part we have in the SD-WAN is the SD-WAN policy. So I will go and start the SD-WAN policy. These are just the information slides. You can go and refer these slides. Everything is listed here. Actually, this is clubbed with some old slide and the new slides. I have to cover these things later on in the redundancy section. Yeah, and you don't have policy here in this slide. For policy, you have different set of slides. Okay, next class we'll start the policy. A policy will take at least it will take 10 classes to complete. So once you complete the template and OMP and policy, your 80% job will be done. And for your CCI, your 100% syllabus will be covered.
Okay, good.
Okay, all right. Thanks everyone. If you don't have any further question, we can stop and we'll meet on next class. That is tomorrow, right?
Tomorrow, yes. Okay.
Tomorrow,
Bye-bye.
yeah, we are going to start the policy. Thanks. Bye-bye.
Uh-huh. Bye.